Okay, for the next activity, we're going to work with a grid system. Now, the coordinate system that we're going to work with has something called an x-axis, which runs horizontally, starting at 0 on the left side. Now, it's important that when you create your x-axis, you have a number on each line. Actually, it's more important to make sure your numbers are equally spaced. So what you could do is you could jump every other and count as 1. Every other and count as 2, 3. But you have to make sure that each number is equally spaced as you build your axis. And this is called the x-axis. It runs horizontally. Going vertically, we have your y-axis starting at 0 again, equally spacing the numbers. We've labeled it the y-axis right there. So what we're going to do in this example, I took two pattern blocks and I've taped them together to create a special unique shape. So it's a combination of a rhombus and a square. Now what I'm going to show you is how you can take your unique shape and do something called translate it. Now what does that mean, translate? Well, it's a fancy math word for sliding. So let's see how this might work. Okay, so the first thing I've decided to do is I took my object, which we can call it a polygon. It's an enclosed shape, no open edges. It's a combination of a square and a rhombus. And I decided to put it on the grid in a location that might make it easier for me to describe how it's moving, because it's going to translate or slide into a different location on the grid system. So what I did was I went with my square section and I lined the 90-degree corner of my square perfectly with my grid line. I did this on purpose because then I can use my grid to help me describe the movement of my shape, of my polygon. So once I put it and lined up that corner perfectly, I traced around my object and I labeled each vertex. So there you can see my object where I've labeled points or vertices A, B, C, D, E, and F, and you can see the outline of my object there. It's important to set your object up first, and then we can start talking about, alright, how can we move this and how can we describe the movement? So my object starts in this location. Now if I take my object and I translate it like this, actually what if I move it here? So if I translate it to this location, could you describe how it's been moved? Watch again. Can you describe how it's been moved using your grid, for example? So I'm just going to mark the bottom vertices. I'll mark the other vertices. Okay, so now it's important to mark the image points because you have to be able to identify where they're located. So object to image. There are a variety of different ways of explaining how you can move from your object to your image. The common technique used in math, we describe the movement along the x-axis first, and then we describe the movement on the y-axis second. So again, starting from your object, how far does it move to the right? And it does move to the right, because if we go from here to here, there's a shift to the right and down. So we break it up into the directions left and right, so we're moving right first, and then we move down. The question is, how many spaces are we moving to the right using your grid system, and how many spaces are you moving down using your grid system? That's a great way of explaining the movement of your shape. Now, in order to clearly describe a translation, one thing you may want to do is choose a reference point. Some vertex on your object. Now my recommendation is choose a vertex on your object that is on an intersect line on your grid. So if we look carefully at this, would it be a good idea to choose B, for example? Is B on an intersect? Well, it's kind of in between. It's closer to this one than this one, but it would be hard to use. Same with C. It's not really on an intersect. D is close, E no, F no. A is right on an intersect. So this would be the best option to choose as your reference point. Now your reference point is going to show, and you can describe the movement of this point, because the description of this one will be very precise because you're starting on an intersect, meaning you're going to end on an intersect on your grid line. So how you describe this movement will also describe the movement of all the other points, because they're all moving collectively as an object. They're all going to move in the same direction. Okay, so let's see how A actually does move. Now remember, we've taken our object, and I said I want you to take your object and move it to this location. So if this is the location it's going to move to, you have to mark and label your reference point. So that's going to be A prime, from A to A prime. Once you've marked and labeled that point, I'd like you to draw something called a translation arrow. Now your translation arrow shows the movement of the reference point from on the object to the same reference point on the image. So it clearly shows the direction of the point on the object. So A is moving in this direction to create A prime, which is a point on the image. That means that all of the other points are going to be moving in the same direction as that translation arrow. So you could draw parallel lines matching your translation arrow, and that would go directly from every point to their image point. But the best way to identify the movement, again, is to break your translation arrow up into two movements. Movement along the x-axis and movement along the y-axis. So the translation arrow describes the movement of point A that was on your object. So let's look at that point and describe its movement according to the grid lines. So if we were to walk along the x-axis, again, we want to only walk as far as we have to get to A prime. So we would walk 1, 2, 3, 4 spaces to the right. So that's 4 right, comma, 1, 2, 3, 4 right, and then how many spaces down? 1, 2, 3, 4 spaces down. So 4 right and 4 down. That describes the translation. So the translation is 4 right, 4 down. Okay, now how could you show that again? Well, when you're talking about coordinates, we don't have to write right or down, because the first movement is always the first the first number shown whenever you show a coordinate pair. So when you're describing a translation, the first number here, 4, means to the right. And in grade 7 and 8, you'll see that that says -4, it means to the left. So it describes, this number describes movement in the x-axis. And the second number describes movement in the y-axis. So because it's positive, it's actually, oh, well, in this case that doesn't make sense, because movement positive would mean that we would go 4 right and then 4 up. But 4 up is not, we don't want to go positive, we actually want to go 4 down. So to say 4 down, according to the point representation, if we were to use our coordinate pair, it should be -4, because -4 actually means down when we're looking at the y-axis movement. So if you're not sure exactly how to use this, you could say 4 down, and that's fine. That's acceptable. Or you could say 4 right. So technically, when you want to move to the right, it's positive. When you want to move up, it's positive. When you want to move left along the x-axis, it's negative, and down is -2. Okay, so if each point is moving 4 right and 4 down, the hard part is, how do we move C if it's not moving on the grid lines? Would we have to guess to see exactly where it might go? Well, no, you don't have to, because you can use your object. Once we've positioned A, and we move A 1, 2, 3, 3, 4 right, and then 1, 2, 3, 4 down, all you have to do is hold your image in the same location, mark your vertices, then you can slide your translation arrow to actually show where the image would become, where the image goes. So F, for example, is here. That means F prime must be here. If we look at B, B is right there. B prime must be over here. Now, why do I say B prime is here and not there? Well, if you look at the object, B is actually to the right of A. So if A is here, A prime is here, B prime must be to the right of A prime, because B is to the right of A. Now, if we look at the relationship B to C, well, C is above B. That means if B is here, this must, or B prime is there, this must be C prime. And which point in the object is above and to the right of C? Well, that's D. And your translation arrow, this must be D prime. E forms a straight line with D. This must be E prime. And again, the translation arrow perfectly matches the translation arrow for A. And if you look, we've labeled all of our points. Now it's just a matter of connecting the dots to form the image. So here's the final solution that shows the translation of 4 right, 4 down from our object to our image. Now, the important features that you need to include: you have to outline your object and label the vertices. Make sure that one of your vertices is on the grid intersect, so just like point A. That way you can use that point as a reference when identifying your translation arrow movement, because you can accurately identify the number of spaces moving right and the number of spaces moving down, or in any other direction. As long as one vertex of your object is on an intersect on your grid, you can do your translation accurately. Okay? Also, make sure that you label and identify the prime points on your image, label and identify your translation arrow, and identify your translation. What is it exactly? So you could say it's 4 right, 4 down, 4 right, comma, 4 down for this one. Or you could say bracket 4, comma, -4, because -4 means 4 down in the y-axis. +4 means 4 to the right in the x-axis. So always x, then y. So always move along the x-axis and then along the y-axis. Hope this helps. Practice, please, with your translations. Okay, now let's take this a step further. So I'm going to put my mirror on my grid paper. It's on a line on my grid paper. So make sure that you mark your mirror line. And then let's see if we can take this, the first image from our translation, and see if we can actually reflect it over the mirror line into this location. Because remember, there's nothing there right now. But we can use our mirror to help us reflect it into a new location. Okay, so now you'll see that I've labeled and identified my mirror line. It's also called the line of reflection. And I've made a dotted line on my grid to make sure it's identified. The next step would be to take your object and start to examine the point location. Now remember, our point of reference on our original object was point A. It is now A prime and it's still on an intersect. Now check this out for support. When you're using a grid, it's actually easier to use your mirror, because A prime is found on this point. How many spaces on the grid is A prime away from the mirror line? Now, because the reason you should do this is because A prime is going to be the same distance from the mirror line on this side as it is on this side. So if you can count how far away it is from the mirror, that'll tell you how far away it should be, the image of this should be on the other side. So when we're looking at the shape A prime, B prime, C prime, D prime, E prime, and F prime, if we rotate, or sorry, if we we've already translated, if we reflect it across the mirror, or over the mirror line, that means our next image will be A double prime, B double prime, C double prime, D double prime, E double prime, and F double prime. So first, let's have a look at how far A prime is from the mirror. It's 1, 2, 3, 4, 5, 6 spaces away. That means if we follow the same line here, and we count, well, that's 1, 2, 3, 4, 5, 6 spaces. So this should be what? Well, it should be A double prime. You're probably thinking, well, A double prime, does that mean the shape's going to be over here? No, this is a reflection. It's not a translation. That means the points that are closest to the mirror line on this side will also be closest to the mirror line on this side. The points that are furthest away in your object will be furthest away in your image. So that means if A double prime is going to be 6 spaces away over here, that means B double prime, well, we're not quite sure how far away it is because it's definitely 1, 2, 3 and a bit, but we don't know for sure how far it is. Are there any other points that we can use to show? This is where the mirror comes in. Now we have to look at the image that we can see through our mirror and try and mark the points that we see. So B double prime should be about here. E double prime should be about here. D double prime is right about here. What's this one? That's F double prime. It's right around there. And C double prime is right about there. So I've done my best to mark it, and if you look, you can actually see locations of the points now. And it should make sense because F is supposed to be in line with, F double prime should be in line with A double prime, right? Because they follow in the same straight line. This is the furthest edge from the mirror, so it should be the furthest edge from the mirror here. That means this should be E double prime, this should be D double prime, and this is C double prime. So the next step would be to remove your mirror, grab your object. Now when you flip this over the mirror line, it's supposed to flip this way. Line up your corner, your reference corner of A double prime. Now you can trace your image. Okay, so as you can see, D is approximately the same distance away from your mirror line. E prime to E double prime, again, approximately the same distance. It's 1, 2, 3, 4 and a bit. So from the mirror line, 1, 2, 3, 4 and a bit. Again, it's an estimate because we don't know exactly, because E prime is not on a vertex on our grid line, but A prime is. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. A double prime is the same distance from the mirror line as A prime. This is our new reflected image. We have to give it a different name than just I. We could call it I. If this is I1, this could be called I2, or we could say it's our newly reflected image over the mirror line shown here. So again, what we've done all together here is we've taken our object, translated it 4 right, 4 down, and then we've reflected it over the mirror line to create our second image. So I hope this helps.